I
Okay, so last time we have been talking about the introduction to chemical reaction. You remember?
yeah.
Okay, chemical reaction, as you remember, is a process in which the reacting substances called reactants are converted into a new
Products.
product. Very good. So inside this, in a given chemical reaction, we transfer reactants into the products. And we have also said that the characteristics of the reactants are completely different from that of the product. Is that not?
Yeah. Yeah.
Okay, we have also seen the three laws of chemical reaction.
There was.
You remember? Tell me
Yeah.
one of them. Tell me one of the three laws of chemical reaction.
Laws of conservation of mass.
Yes, the first
Law of
one is
definite proportion.
law of conservation of mass. Another is the law of,
Definite proportion.
yes, the law of definite proportion. And the third one is the law of multiple proportion. Very good.
Yeah.
Okay, which law is known as
Okay.
the law of indestructibility of matter?
Law of conservation of mass.
Yes, the law of conservation of mass is also known as law of indestructibility of matter. And it
Yeah.
states that the amount of a reactant is always equal to that of the product.
Yeah.
Okay, the law which states that always a given compound contains the same element combined together in the same proportion by mass is,
Law of definite proportion.
yes, the law of definite proportion. So you have to remember each and everything about our last time's
Yeah.
lesson. Today we are going to start chemical equation.
Okay.
Okay, mata dureen keenya har'aan tana chemical equation kayyuu kana now let us start with definition of a chemical equation. Chemical equation is a shorthand representation. It is simply a shorthand representation of chemical reactions in terms of symbols and the formulas, okay? Yeroo
Yeah.
chemical equation yeroo jennu maal jechuudha? Shorthand representation idhaan chemical reaction tokko bakka buusuu keenya. Now we remember that chemical reaction involves transformation of reactants into products. Kanaaf keessaa qaba chemical reaction. Saniifuu chemical reaction kana in terms of symbol and formula kaa'uun maal jedhamee yaamama? Chemical
Chemical
equation
equation.
jedhamee yaamama jechuudha. So in a chemical equation, yeroo hunda chemical equation tokko keessatti the starting substances are called the reactants. And the newly or the new substances produced are known as the products. Yeroo hunda chemical equation keessatti starting substance reactant dha. And the new substances are called the product jennaan. Now, reactants are written on the left-hand side, and the products are written on the right-hand side of the equation. Yeroo hunda reactantiin gama left side'iitiin jira, and the products are on the right-hand side'idhaan jiraata jechuudha. Yeroo hunda the reactant and the product they must be separated by an arrow. Yeroo hunda reactantidhaaf productiin arrowdhaan adda ba'an jennee jirra. So an arrow is placed between the two sides to indicate the transformation of the reactants into the products. Kana nu agarsiisa jechuudha. Now let us see writing chemical equations. Chemical equation akkami barraamata waan jiru yoo laallee how we can write a chemical equation yoo laallee in writing chemical equation instead of using words, chemical symbols and the formulas are used to in writing chemical equation instead of using words, jechoota fayyadamuurra chemical symbols and the formulas are used to represent the reactions. Reactionii san bakka buusuudhaaf symboliidhaa fi formulaadha fayyadamnaa jechuudha. Now, to steps to write chemical equations, the first is to write a word equation. Jalqaba maal goona word equation da barreessina jechuudha. Chemical equation tokko yeroo barreessinu jalqaba irratti word equation da barreessina. So a word equation is stated in a word. Kana jechuun maali wantoota reactionii san keessa jiran jechaan barreessu jechuudha. For example, word equation for the reaction between sodium and the chlorine to produce sodium chloride is written as follows. Fakkeenyaaf reactionii sodium fi chlorine jidduu godhamee sodium chloride produce godhu word equation dha yeroo bakka buufne we have to write sodium plus chlorine gives us or an arrow sodium chloride. Now this is a word equation jechaan barreessu jechuudha. Wantoota achi keessa jiran sana akkuma jiranii jechaan barreessuudha. So note that we read this plus sign as react with jechuun plus sign kana maaliif itti fayyadamu react with jechuudha. Abaluutu abaluu wajji wal nyaata jechuudha. Kana jechuun sodium reacts with chlorine jechuudha. And the arrow kana ammas it is reads as arrow kun hiikkaansa it may be to produce ta'uu danda'a, to form ta'uu danda'a, or to give ta'uu danda'a, or to yield ta'uu danda'a jechuudha. Akkana jechuun maali? We can use sodium react with chlorine to produce jechuu dandeenya sodium chloride, or sodium react with chlorine to form sodium chloride jechuu dandeenya, or sodium plus chlorine or sodium react with chlorine to give sodium chloride jechuu dandeenya, or sodium react with chlorine to yield sodium chloride jechuu dandeenya jechuudha. So arrow kana hiikkaan isaa yookaan bakka isaa yeroo dubbifnu we may say to produce jechuu dandeenya, or to form jechuu dandeenya, yookaan ammoo to give jechuu dandeenya, akkasumatti illee to yield jechuu dandeenya jechuudha. So hiikkaan isaa isaan hanga kana jechuudha. Now write the symbols. Step lammadaa irra dhufna. Steps to write a chemical equation. The second step is that write the symbols and the formulas for the reactants and the products in a word equation. Word equation ammaan tana arma walitti dubbanne kanaaf simboolii isaanii barreessu akkasumatti illee formulaa isaanii barreessu step duraati jechuudha. For example, in the above word equation we have sodium and the chlorine. So we have to write sodium in terms of symbol, it is Na, and the chlorine in terms of symbol is Cl2. We have to write in the form of Cl2 because chlorine is a diatomic molecule. Chlorine in diatomic molecule ante hala sanin barreessina. Then finally we will have the formula for sodium chloride. Now this is the chemical equation. Finally, chemical equation in Kanaju. When we say chemical equation, it is what? Representing the chemical, or it is the shorthand representation of the chemical reaction in terms of symbols and the formulas generation. Sanifu in terms of symbols and the formulas it is considered to be a chemical equation. Now finally we have to balance the equations. Equation kana balance godhuudha qabna jechuudha. Yeroo balance goonu fakkeenyaaf we have to use during balancing a given chemical equation we can use only a coefficients. Now we will see the details of balancing chemical equation later on this lesson. Ammaaf garuu step inni dhuma chemical equation kana balance godhuudha jechuudha. Balance godhuudha. Balancing means it is the process of giving appropriate coefficients on both the reactant and the products so as to have equal number of each atoms. Lakkoofsa atomii reactant fi product irra jiru wal qixa godhachuudhaaf coefficientiilee kennuu coefficientii mijaawaa ta'e kennuu tokkotu balancing equation jedhamee waamama. San waa'ee isaa bal'inaan irraa dubbannaa mata dureef dandeessa jechuudha. Now let us continue with the other portion, that is generally akkuma waliigalaa yoo ilaalle any chemical equation must fulfill the following conditions. Chemical equation fedhee jechuudha wantoota armaan gadii kana guuttatee dhufuudha qaba. Inni jalqaba the equation must represent true and possible chemical reactions. Equation achi jiru sun reaction dhugaadhaan jiru tokko bakka bu'uudha qaba. Akkasumatti illee kan danda'amu reaction danda'amu jechuudha. Waan hin danda'amneef inni achitti abaluu fi abaluu wal nyaata yookaan react godha jechuu hin dandeenyu. Now the equation it must represent a true and possible chemical reaction ta'uu qaba. The next one is the symbols and the formulas must be written correctly. Symbol in elementary TV formula elementary sani sirri barraa'uudha qaba. For example, we can use for sodium Na, not N. Elementary biraa bakka biraa geessinee fayyadamuu hin dandeenyu. Symbolii sirrii ta'e tokko fayyadamna. The element hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, they always exist as a diatomic molecules. Elementoota kana bakka arganetti hydrogen yookaan arganetti simboolii H qofa fayyadamuu hin dandeenyu. We have to use H2. Yoo nitrogen argine we have to use N2. Yoo oxygen argine we have to use O2. Yoo fluorine argine we have to use F2. Yoo chlorine argine we have to use Cl2. Yoo bromine argine we have to use Br2. And yoo iodine argine we have to use I2. Because this element exists, they exist as a diatomic molecules. Bifa diatomic molecule waan argamaniif reactionii keenya san keessa elementoonni kun yoo jiraatan we have to use them or we have to use them as a diatomic molecules. Finally, the equation must be balanced. Dhumarratti equation kun balance ta'uudha qaba jechuudha. Okay, a chemical equation has both qualitative and quantitative meanings. Chemical equation tokko meaning adda addaa lama qaba. Isaanis qualitative fi quantitative. Now, as you remember from the lower grades, qualitatively, a chemical equation includes types of reactants. Kun maali jenne yeroo hunda types wanni inni bakka bu'u quality types or kinds bakka bu'aa jennee jirra. Quantity jechuun ammas it stands about the number lakkoofsa hangam takka elementiin achi jiru sun yookaan compoundin achi jiru sun habbaa meeqa waan jiru deebisaa kanna. Qualitativein ammoo elementiin achi jiru sun eenyummaa isaati. It gives us the identity of that substance. Eenyummaa isaa yookaan the kind or the types of that element bakka bu'aa jechuudha. Kanaafuu qualitatively maal jenne a chemical equation indicates the types of the reactants and the products. Qualitatively akkas jenne. Quantitatively ammoo chemical equation expresses the relative numbers yookaan amount of moles yoo ta'uu danda'a or it may be in terms of a molecule ta'uu danda'a or in terms of masses of the reactants and the products. Haala kanaan nu ibsuu danda'a jechuudha. Waan biraa balancing chemical equations mata duree jettu. Balancing chemical equations yeroo jennu according to law of conservation of mass irra yoo deebine according to the law of conservation of mass atoms are neither created nor destroyed during a given chemical reactions. Maal nuun jee law of conservation of mass in atomiin created isn't ta'u destroyed isn't ta'u amount of reactant must be equal to that of the product yennutti. As a result, sababa kanaaf jechuudha number of atoms of each element remains the same before and after the reactions. So lakkoofsa elementiidha reaction isa keessa jiru wal qixa. Before and after the reaction. Reaction duraa fi reaction boodaas jechuudha. Kanaafuu jechuudha. Therefore, the main reason why all chemical equation must be balanced is just to obey the law of conservation of mass. Equation the reason behind this balancing an equation is what? To obey the laws of conservation of mass. To obey the law of conservation of mass. One equation is to balance goonu seera conservation of mass jedhamu kana obey godhuudhaaf yookaan ajajamuudhaaf jechuudha. Obey godhuudhaaf yookaan ajajamuudhaaf jennee okay to balance a chemical equation tokko balance godhu jechuun It means to equalize the number of atoms on both sides of the equation. Atomoota jiran kanneen reaaktaantiidhaa fi piroodaaktii irra jiran walqixa godhuu kanaatu baalaansi jedhama jechuudha. Okay, akkamitti garuu by putting appropriate coefficients in front of the formulas. Formulaa keenya fuula duraan appropriate coefficient kaa'uudhaan. Now you remember about coefficient and the subscript from the lower grades. Coefficients are numbers written in front of a symbols or a formulas. Whereas the subscripts are what? The number which are written as the right bottom hand sides of an element. Jennee jirra jechuudha. Garuu ammaan tana equationin tokko baalaansii ta'uudhaaf we have to use only the coefficient. Coefficientii qofa fayyadamna jennee. Only two methods of balancing chemical equation will be discussed under this topic. Adeemsa kana keessatti chemical reactionii keenya yookaan equationii keenya baalaansii godhuudhaaf unity kana keessatti waa lama qofa laallaa. Isaanis inspection method adeemsa inspection jedhamuu fi akkasumatti illee adeemsa least common multiple method jedhamu yookaan adeemsa LCM method jedhamu laallaa jechuudha. Okay. Now let us start with the inspection methods. Inspection method, as you remember, it is a method of balancing chemical equation by simply trial and error methods. So lakkoofsa mijaawaa tokko itti yaallee lakkoofsa ni ta'a jennu adeemsa itti keenyu. Kanaatu inspection method jedhamee waamama. Saniifuu most simple chemical equation can be balanced by using this method. Reactioniin baay'ee salphaa ta'e tokko jechuun ijumaan laallee haala salphaadhaan balaansii godhuu kan dandeenyu adeemsa kana fayyadamna. Okay, so balancing an equation by inspection means jechuun maal jechuudha? To adjust coefficients by trial and error until the equation is balanced. Trial and error yaaliidhaan itti yaalaa hanga equationin keenya baalaansii ta'utti coefficientii jijjiiraa laalu adeemsi akkasiisa inspection method jedhamee yaamama. Okay, yeroo kanatti we have to follow the following 4 steps to balance a chemical equations. Step 1 is write the word equations. Step inni jalqaba word equation barreessuudha. Step inni jalqaba we have to write a word equation. Now we have to write the correct symbols and the formulas. Correct symbol idaafi formula for both the reactant and the product barreessina. Achi booda place the smallest whole number coefficient is in front of the symbols and the formula until the number of atoms of each element is the same on both sides of the equation. Achi booda coefficientiilee mijaawoo ta'an tokko kennaa laaluudha. Hangami kennina until we will have equal number of atoms on both the reactants and the product sides. Hanga reactantiidhaa fi productii gubbatti lakkoofsota atomoota walqixa argannutti akkasin lakkoofsa kennuudha jechuudha. Now this is method of balancing by using inspection method. Kabira stepin inni afraffaatii fi inni dhumaa maal jaa checking. Finally you have to check whether each atoms are equalized or not. Checking jechuun by counting the number of atoms on both sides of the equation, make sure that the atoms of all the elements are balanced. Also the coefficients are expressed as the smallest whole number ratio. So atomiin jiru hundinuu balanced ta'uu laalija. San gubbaadhaan ammoo coefficientiileen jiran garuu they must be expressed in terms of their smallest ratio. Smallest ratio dhaan ta'uu qaban jechuudha. Fakkeenyaaf ammaan tana 2 yoo jiraate smallest ratio isaa akkanaa miti. Xiqqeessinee kaa'uudha qabna. Over 2 jenneeni kanallee over 2 jenneeni. Now this cancel ta'a. It becomes 1. Here it becomes 2. Then here it becomes 1. Now this is the smallest ratio. We cannot write it in the form of the first way. We have to make it in the smallest possible whole number ratio. Now finally we have checked the equation. Now let us continue with the other part of this equation. Note that when you balance equations, do not change any symbols or formulas of any compounds. Jechuun yeroo balance equation tokko balance goonu we cannot change jijjiiruu hin dandeenyu, symbol illee jijjiiruu hin dandeenyu, formula illee jijjiiruu hin dandeenyu jechuudha. If you change a symbol or a formula, it is no longer represents the element or a compound required by the equations. So ammaan tana symbol isa yoo hajii jijjiirru taate fakkeenyaaf instead of using for magnesium Mg fayyadamuudha dhiifnee MnO fayyadamne dogoggorree wanni kun equationii barbaadame san bakka bu'uu hin danda'u jechuudha. Okay? It no longer represents the elements or the compounds which is required in the equation. Sanifu, this means simply we have to use the correct symbols or formulas. Symboli nuti fayyadamu qabnu isa sirriidha ta'uudha qaba waan jiru nutti himu jira jechuudha. Asirratti then for example fakkeenyaaf consider the equation for the reaction between magnesium and oxygens. Magnesium idaf oxygen yitu reaction jiru laalija to produce magnesium oxide yoo laalle. First of all, we have to write the word equations. Now magnesium is written in word in such a way, then oxygen can be written in such a way, and magnesium oxide can be written in such a way. Then finally, we have to change on the second step, we have to change this into symbols and the formulas. The symbol for magnesium is Mg, and last time we have said that oxygen must be written in the O2 form because it is one of the diatomic molecules. So in case we encounter the 7 elements which are written in the diatomic molecule, we have to use only the diatomic form. Then finally, we have to write the product, that is the magnesium oxide. Okay, now the equation is now, it is unbalanced because the number of atoms on both the reactant and the products are not equal. That means on the reactant side, we have only one magnesium. On the product, we have only one magnesium. So the number of magnesium is equal, but here we have 2 oxygen atoms, but on the product side, we have only 1 oxygen atom. Now, this indicates that two atoms on the reactant are not equal with 1 atom on the product. Now, this indicates that the reaction is simply unbalanced. Reaction is unbalanced. Then we have to use appropriate coefficients. Put coefficients to balance the equation. So coefficient adda adda kanneen trial and error laaluu dandeenya. Fakkeenyaaf if you place 2 before magnesium oxide, the number of oxygen on the reactant and the product side becomes equal, but there is a change on the number of magnesium. That means on the product side, the amount of magnesium is 2. Now, as you remember, the coefficient multiplies all the substances in this reaction or in this formula. 2 indicates there are 2 magnesium atoms and the 2 oxygen atoms. Now, the amount of magnesium are not equal. Now, we have to make the number of magnesium equal by giving coefficient 2 here. Now, if you write in such a way, 2 Mg plus O2 gives us 2 MgO. Now this equation becomes balanced. By we have used trial and error method for balancing this equation. Okay, so one amount anaso ina kanarra dubbatu jira. Asimal ja oxygen is not balanced je sirrida. Lama takka sirrida. There are 2 oxygen atoms. On the left side and only 1 on the right side. Hence, sanifu jechuudha, place the coefficient 2 in front of magnesium. 2 oguu keenye ammallee unbalanced dha. Now magnesium is not balanced. There is 1 magnesium on the left side and the 2 on the right side. Thus, place the coefficient 2 in front of magnesium. Now, after this, it becomes 2 magnesium, 2 2 magnesium plus oxygen gives us 2 magnesium oxide. Now the equation is already balanced. Finally, you have to check. We have to check this answer. Finally, we have to check the answer. Finally, we have to check the answer. Checking the answer, there are 2 magnesium atom, 2 oxygen atom on each sides of the equation. Therefore, the equation is correctly balanced. Try the exercise. That is exercise 4.2 from your textbook by using inspection methods. So may reaction as gubba jiran kana adeemsa inspection method kana fayyadamuudhaan balance godhiin siin jaa. Okay. Is it clear? Abdul Bari.
Niin tekee.
Aya, wadaan gammaa soina kun ifa miti.
Akka ajaa'ibatti wallahi.
Aya, ida barra jechuudha.
Fuuldura kana goonume gaaffii tokkoffaa soodiyem pilaas echitoo kana.
Aya, sodium plus
Echitoo.
trial and error method ida fayyadamna. Aya, mee haalaallu. Hangi sodium as gubbaa jiru takka product irra ka jirus takka miti.
Was.
Homaa rakkoon qabu. Asitti hydrogen yoo laallee hydrogen lamaa jira. Hydrogen garuu asirra takka bakka kana takkaa jira. Product irra asammoo lamaa jira. Sadii miti.
Was.
Saniifuu hydrogen irra rakkootu jira jechuudha. Okay. Dalagoo jirta?
Ittiin jira ittiin jira.
Aya, mee yoo kanneen hydrogen kana ol qixxeessuu dandeenya. As sadii jira, as lamaa jira. Mee bikka kana meeqaa kanninu? Lamaa kanninu mee asitti? Lama yoo kanninu lakkoofsa hydrogen as jiru kun 4 ta'e miti.
Was.
Eegaa lamaan tun hydrogenis ni baay'ifti, oxygen illee ni baay'ifti. Saniifuu lakkoofsa hydrogen as ture as jiru 4 ta'a. Gamana ammoo 3 ta'a. Saniifuu asitti yooni lama kenne lamaan tun hydrogen illee oxygen illee sodium illee ni baay'ifti. Saniifuu hydrogen lamaa jira, lamaa fi lama 4 ta'a. Asirra ka jirus lama bakka lama 4 ta'a. Wal qixa ta'e miti.
Was. Luki.
Ayya, garuu amma rakkoon lakkoofsa soodiyeemii qofa bira jirti. Zaatis soodiyeemiin as lamaa jira, as tokko jira. Baalaansi godhuudhaaf I have to put number 2 here. Okay.
Okay.
Amma baalaansi ta'e moo hin taane, we have to check. You have to check each and every atom on the reactant and the product side. Okay.
Okay.
Now we have balanced this equation by using only inspection methods. By simply contemplating, okay, by simply contemplating the numbers that makes each group is equal. Akkanuma yaanneetuma keenya jechuudha. Lakkoofsa meeqa yoon kaa'ee kun naa dhufa adeemsa tokkollee kan fayyadamu jechuudha. So adeemsi kanaa kun inspection method jedhama. Most of the time it is used to balance some simple chemical equations. Equationii tokko kanneen complex hin ta'in xiqqaa balance godhuudhaaf nu gargaara jechuudha adeemsi kun. Gaafiin lammataa tun as you consider now this is simply balanced, okay? Gaafiin
Balance taatee jira.
balance ta'e jira. Each and every atom, for example, if you consider calcium, here we have 1 calcium, on the product also 1 calcium. Wow, how many carbon atoms? 1 carbon.
1.
On the product also 1 carbon. Now 3 oxygen atom, here we have 1, here we have 2, 2 and 1 becomes 3. So each and every atoms on both the reactant and the product sides are equal. Now you have to use the same methods for balancing the rest of the equations. Let us continue with our next portion. The next method of balancing chemical equation is the one which is called the LCM methods. Okay. In the LCM methods, the coefficients for the balanced chemical equation are obtained by taking the LCM of the total valency of the reactants and the products. Adeemsa kana keessatti total valency dha fudhanna. Achi booda wanni nuti goonu then dividing it by the total valency of the reactants and the products. All the necessary steps to chemical equation by LCM methods are shown on by the above examples, shown by the following examples. Yeah, may example 2 kan alallu LCM akkatti fayyadamnu. Okay, when aluminum reacts with oxygen, aluminum oxide is formed. Aluminum in yeroo oxygen wajjin nyaatu aluminum oxide tu uumama. First of all, write the chemical equation kana barreessina. Kana barreessuudhaaf first we have to write the word equation, that is aluminum react with oxygen to form aluminum oxide. Now the next step is to change these word equations into symbols and the formulas. Word equation kana gara symbol fi formula jijjiiruudha qabna jenne gara symbol fi formula jijjiiruu qabna jenne. Now the symbol for aluminum is Al and the oxygen is O2. Because oxygen is a diatomic molecule, we have to use number 2. Then the product becomes aluminum oxide. Okay, aluminum oxide ilata. Then take the total valency. Total valency of the valency aluminum ida aslalla. Valency aluminum plus oxygen gives us what? Al2 O6 ida nukhanna ja O3 nukhanna ja. Valency aluminum is sadi. Valency oxygen lama ni adan. Garuu total valency ida fudhachuu qabna. Oxygen lama jira. Ka tokko lama yoo ta'e kalamaa meeqa ta'a jechuudha? Lama bakka lama afurta. Asitti aluminum yoo fudhatte aluminum tokko valency isaa sadi jenne as garuu lama jira. Lama bakka sadi jaha ta'a jechuudha. Oxygen illeen oxygen tokko valency isaa meeqa? Lama miti. Amma garuu sadi jira, sadi bakka lama jaha ta'a jechuudha. Saniifuu LCM 4, you have to take the LCM 4, 3, 4, 6, 3, 4 and the 6. Their LCM becomes 2, 12. Now divide 12 by each valency. 12 by 3 means it becomes 4. Now use that 4 as a coefficient for aluminum. Then divide 12 by 4. It becomes 3. Now use that 3 as a coefficient for oxygen. Now this gives us divide 12 by 6. It becomes 2. Now use that 2 as a coefficient for aluminum oxide. Now the equation is already balanced. You can check by using any method you want this. The balanced equations becomes that. Okay, now let us continue with the other example. Now, when iron reacts with water, that means iron 3 oxide and hydrogens are produced. First, we have to write the word equation. Iron plus water gives us iron 3 oxide plus hydrogen gas. Now, write the word, the chemical, the symbols and the formulas for each groups. It becomes Fe plus H2 gives us FeO2. Fe plus H2O gives us Fe2O3 plus H2. Then the next step is to write the valency of each groups. For iron 3, for hydrogen 2, for oxygen also 2. Hydrogen lama akkatti dhufanii beeytaame watarii keessatti valensiin hydrogen lama ta'a. Maaliif? Hydrogen, it is valence is 1, but the total number of hydrogen here is 2. Now we have to multiply 2 by 1, it becomes 2. For oxygen, it becomes also 2 dha ta'a jechuudha. Achi booda for iron in tokko sadii qabaachuu ture as keessatti jechuudha. Ka lamaa garuu jaha ta'a. Isaan lamaanuu ka oxygen tokko lama, ka sadii jaha ta'a. Hydrogen tokko tokko qaba, ka lamaa garuu lama qaba. So we have written the valence above each symbols barreessinee jirra. Now we have to take the LCM for this all valence. For 3, for 2, and for 6. The LCM becomes 6. Divide that 6 by 3. It becomes 2. Now use that 2 as a coefficient for iron. Divide 6 by 2, it becomes 3. Now use that 3 as the coefficient for water. Divide 6 by 6, it becomes 1. Right, use that 1 as a coefficient for iron 3 oxide. Now we cannot write number 1 because the symbol or the formula by itself represents 1. Now divide 6 by 2, it becomes 3. Now use that 3 as a coefficient for hydrogen. Now this equation, if you compare, the number of each atom on these reactions becomes balanced. Balanced ta'ee jira jechuudha. Isa kana check gootaa jechuudha. Now let us come to see the final example. The final example on this. The final example is example 4. The reaction of iron sulfate with aluminum nitrate would form aluminum sulfate and ammonium nitrate. Jalqaba irratti ogguu warriidhaan barreessinu ammonium sulfateidhaa fi aluminum nitrateidhaan react godha. Bu'aan isaa the product is aluminum sulfate and ammonium nitrateidha. Now this group it consists of different polyatomic molecules. Polyatomic of keessaa qabanii polyatomic ions of keessaa qabanii polyatomic ions or radicals of keessaa qabanii saniifuu polyatomic ion kana nitrate kana walumatti baalaansiin isaa waanidha ni yaadatta. Kanas walumatti ammonium baalaansiin isaa waanidha. Kanaatuudha akkasii yaadatta jechuudha. Ka aluminiyemidha tokko, 3 ka sulfateidha 2 ka ammonium asitti akka ka kanaatis takka. But we have to use the total balance here. Balaansii nuti fayyadamuu qabnu garuu balaansii waliigalaa waan ta'eef as keessatti ammoniyeemii kana yoo fudhatte baalaansiin isaa takka jenne takkitti san lamaan yeroo baay'ifne 2 ta'a jechuudha. Sulfatiin tokko baalaansiin isaa takka. Sulfatiin tokko baalaansiin isaa 2. We have to write 2. Aluminiyem tokko baalaansiin isaa 3. Nitrate tokko baalaansiin isaa meeqa? Takka. Amma garuu nitrate 3 jira, takka bakka 3 ta'a. Aluminiyem tokko baalaansiin isaa 3 bakka 2 6. Sulfate tokko baalaansiin isaa 2 bakka 3 6. Ammonium tokko baalaansiin isaa takka, nitrate tokko baalaansiin isaa takka. Now take the LCM for 2, 3 and 6 and 1. Then 6 is the LCM. Divide 6 by 2. It becomes 3. Now use that 3 as the coefficient for ammonium sulfate. Then divide 6 by 3. It becomes 2. Now use that 2. Now use that 2 as the coefficient for aluminum nitrate. 6 by 6 is 1. Now use that 1 as a coefficient for aluminum sulfate. But we cannot write number 1 because this formula stands 1. Okay, 6 by 1, it becomes 6. Now use that 6 as a coefficient for ammonium nitrate. The equation is already balanced. We can compare each and every atoms on both the reactant and the product side, they are equal. Now if you compare, there are 12 nitrogen atoms, 24 hydrogen atoms, and 3 sulfur atoms, and 30 oxygen atoms, and 2 aluminum atoms on both sides of the equation. That the equation is correctly balanced. Now this method of balancing an equation is said to be the LCM method of balancing an equation. Hi, Abdul Bari.
Oye.
We are left with the last